Good afternoon and welcome to today's session on concept of Geoweb services and Geoportal. So we'll continue today from the last slide what I have shown you yesterday, where the web service was a question mark, that if websites are like google.com, then what is the web service? So today we'll try to understand this particular concept, and if any questions, you please ask and be ready for the interactive session. And also today we have created one poll for all the participants. Some basic questions are posted there. Please participate on polling. So 3-4 questions are there, and then we'll have the interactive session. I will take these questions in end of the session. So yesterday I discussed about the GIS system architectures, where I was showing you one basic components of GIS, where the database server and the core application of business logic of GIS was shown. And finally, we have seen that it can deliver two kind of important outcomes to us. One is for the decision makers or planners as a decision support system, and next is a information system. If you see in general, when you have the data in database and you are processing this data, and then it will become the information, and based on this information, whatever the system we are developing or presenting to the users, that will be known as the information system. So data and information, that difference you have to understand. But another important point what I was talking yesterday was basically on the decision support system or decision makers. So here this is another important outcome of GIS, where we can incorporate our model, and this model basically will generate the scenarios, and these scenarios are known as a alternative. It will not give any final decision, but it will prioritize the alternative. Based on this, the decision maker can select the or can do the final decision on that. So these are the things what we are doing in the GIS. And also I explained you about the three important components, basically as a database server, as application server, and hardware. So what are these database server and application server? Basically, if you see in the standard or a desktop based or single user environment, generally we'll be storing our data in a different file formats. Or sometime if you see take the example of MS Word, so any textual data or any data where you need some formatting or presentation of the text or documents. The other way you may be using called as Excel data sets, MS Excel. But the database management system is another form, basically known as a DBMS in IT, where you will be storing your data in the tabular form. So further, the DBMS was enhanced or as a RDBMS, where the relational database management system, basically concept of or implementation of rules from Dr. E.F. Codd was there for the DBMS. And then later stage, the nature of kind of data was slightly changing, like slowly the multimedia data is also becoming the part of database system. The later stage, people have started to use DBMS concept to store and manage the geospatial data like raster and vector. So then the concept of object orientation in database was introduced. And in fact, you can see that the Oracle 9i was the first RDBMS, where the concept of ORDBMS or object orientation was introduced. And when this kind of database were available in the industry, these databases are quite useful for the GIS users also. So based on this, the multi-user GIS or network-based GIS or today internet or web-based GIS has emerged, and nowadays it's a very popular things. So these are the similar concept what we are using, but standard RDBMS and DBMS are not being used in case of GIS or for the geospatial data. So we have to have a database system which have the basically capability of object orientation in database. So that is very important, because if you see the vector and raster data, what we are storing or we are managing in the GIS environment, this is basically a different data type which is not available in any standard DBMS or RDBMS. So we have to create the object, and then these objects can be used as a data type. Now, if you another important consideration, what you should keep in mind when you are using any online GIS or trying to build a online GIS, that special referencing system, or you have to develop a GIS framework, which is very important and mandatory for your database. So when you are storing or managing data in database management system like ORDBMS, so important consideration is special referencing system. So I have just displayed here one basic or simple example to understand this concept of the spatial referencing system. If you see the different level of planning, basically, suppose you take the India as an example. If you are making a national level plan, generally the maps are required on 1:250,000 scale. You may be knowing that to generate the 250,000 scale maps, you need at least the 50-meter spatial resolution satellite data. So that is very important. So here 50-meter spatial resolution and 250,000 scale maps generally are required for the national level planning. In India, we have nowadays in practice to use the Lambert conformal conic or LCC projection system for this, and the datum as a WGS84. So WGS84 datum is basically global datum, or we can say the open datum, and here basically the matching of the international boundaries or the country boundaries are very compatible. And to do this, internationally this WGS84 is adopted and accepted in India also under open series map policy of government of India, and this data anybody can use for data creation and sharing. The same concept is being used for the different projects at national level to local level. Here I am just giving you an example that what do you mean by spatial referencing system. Yes, it required little more study on the concept. Maybe in this course we are not covering this part in detail, but this is an important consideration when you are designing a database for GIS, especially for the online GIS. So here your example is given for the national data, which is Lambert conformal conic like LCC projects and WGS84. If you move down, like at the state level planning, the 1:50,000 scale maps are being used, and here again sometime for few states we are using the LCC projection, and for some state that we are using TM projection based on the shape of the state, whatever shape or boundaries are there. So again datum will be WGS84. If you go down up to the 10,000 scale mapping, where the urban bodies or the city level plannings are being done, or town level plannings are done, here the projection like UTM projection is in practice most of the time, because UTM zones are available based on your location. You can decide, and again the datum is WGS84. The further if you go up to the 500 scale, again in the house level planning, then again UTM and WGS84. These are the, you can see here, although the data is same here, but projection is changing. And very interestingly, whatever data you are getting in internet nowadays, either through the Google Maps or ISRO Bhuvan portal, and these are not the projected data. These are basically geographic coordinate system and WGS84 datum, and the user has to project this data as per their requirement. So this thing you have to always remember. And the geographic coordinate system is basically a general system. Here no projection is defined. So based on your requirement, generally it is recommended to reproject this data as per your as per your project. But if data is not available for download, the question will come, then how I will reproject it. But in the web service based architectures, or what you are going to learn during this course, online services whatever are available, you can apply the projections on that also. So easily it can be done through any standard GIS software or through portal itself. So this is just things, just important thing what you have to keep in mind, and that is basically on the spatial referencing system. So next, when you have very clear idea about the kind of database you are going to store and is using the RDBMS or ORDBMS, then you have a clear idea about the different spatial referencing system. Then the kind of GIS you are going to publish or access from the internet are basically known as the internet GIS, enterprise, distributed, mobile, cloud, and so on. So yesterday I focused a little bit on the internet GIS, but let us try to understand very quickly what is this enterprise and distributed GIS. So enterprise GIS is basically a closed user group GIS, you can say, for a big organizations. Here it works in a basically LAN kind of environment, so that you can manage your own servers for data storage purpose, and also for the application storage purpose, and your users will access this complete data and application as per the user's requirement. Typical example here I can give you. For example, if you are involved in the say land use mapping or land cover mapping for 10,000 scale or 50,000 scale for any region, and then for this purpose you will be using satellite image, for example, if it is a list 3 data as example. So suppose one set of data set, this 3 data is having the 10 GB in size, for example. So 10 GB data, if 100 people are involved in mapping activity, so you have to make the 100 copy of 10 GB. So in nutshell, the organization has to spend the money on to the storage part, so that everyone will have the copy of this data, so that they can do the mapping. But in the production environment or in the GIS industry, this is not the way people will be doing. Here they will be setting up their own enterprise GIS environment. They will keep only one copy of this data, so that everyone will access the same data, and here the performance will be same, and so no duplicate copy will be created of the data. Similarly, no duplicate copy of the software. So here the management of data and software will be very easy. If any updates are there on this data sets, so you update in server, automatically it will be available for all the user. Otherwise you have to send the copy of this data to everyone. So this is a basically kind of ERP. What yesterday somebody was asking, can this GIS be part of the ERP? Yes, and this is an enterprise concept. Same thing is being used in the GIS also. Of course, it is a network-based GIS. The next important GIS is the distributed GIS, which works on the service-oriented architectures. Here, idea is basically we'll be publishing or accessing the GIS data in the form of XML, say extensive markup language, and these XMLs sometimes are also modified as a GML or something else. So then the data flow from server to client and client to server will be based on the XML document. Here the idea is to achieve the interoperability between the different data formats and data standards. So typical GIS environment, or maybe this interoperability is very important in the other kind of web application or software application. For example, suppose somebody is developing their database or creating database in the Oracle RDBMS, or some other person is creating in the MySQL. And now if you want to make a connectivity or the linkages between two applications, if they are not adopting the service oriented architecture, then it will be a little difficult. In fact, sometime you will not get the professionals or the skilled person to operate both the database, or sometime the organizational policy or security policy may not allow you to do this. So in this case, if you want make a connectivity or basically a communication between these two kind of application or database, then you have to adopt the service oriented architectures. So same concept in GIS also will be using. Maybe server A or organization A is creating their vector data in the shape file, and the organization B is creating data in the maybe SVG or vector for other vector format like PostGIS or ArcSD or Oracle Spatial. So if both are publishing their data as a service or in the distributed architectures, then we can achieve the interoperability, so that I can read some part of data from server A and some part of data from server B, and I can develop or design my own application. So this is a typical example, and we'll be learning little more on this concept in the coming slide. And one of the typical example of this distributed system you can see nowadays in internet is like a Make My Trip or maybe yatra.com. There are some travel agencies. So although they are not operating any airlines, but they are able to give you the facility to book the any air ticket from any airlines. So how they are able to do it? In general, if you see, no airline will allow anybody to access directly their database as per their business policies, as per their security concern and all. But since they are publishing the data as a service, so the third party is able to consume these all the services in common platform. It's a very interesting or very successful example what you are getting in internet nowadays. Same thing if it is happening in the GIS, then definitely we can develop the different kind of application, or user can develop the user defined application at user end. So we have kept one demonstration for this activity in the last of this session of this particular program. So quite interesting, where if you implement the distributed architectures, then nicely you can build the different kind of application for your projects or for your organization requirements. So another important GIS which is known as a mobile GIS nowadays, since you are knowing that the smart mobile phones are available with all the users. Now the question is, can I use this mobile for my GIS activity? But you know, we are very much aware that the mobiles are having very limited computation capability. Mobiles are having very limited storage capability. Then how to do it? How to use this thing? But GIS has now advanced, and nowadays you can perform many GIS operations mobile itself. So little bit we'll be learning about it. And one important terminology or concept is being popularized nowadays is basically called crowdsourcing or public participations in GIS, especially for data collection, reporting, or maybe similar other activities. So yes, it is possible nowadays, and the mobile GIS also is one of the part of the network-based GIS. Let us now a little bit try to understand about the internet for GIS. Here the online access of the data will be available. You can perform the queries, you can do the visualization, and today the visualization is not limited to 2D visualization like atlases. So nowadays the 3D visualizations are very popular in the internet domain for GIS. You can do the sharing and distribution of data here, and the GIS data analysis and processing are very much possible in the internet based GIS. So online transaction processing of data, like you can create new maps, you can update the map, you can edit the attributes. All these things are possible in internet based GIS. And very important and interesting facility or services available in internet GIS is basically integration of real-time data into GIS. So for example, suppose you have set up the some in situ observatory from continuous collection of some data, for example rainfall data, some wind speed, other climatic data set, or maybe for urban planners, like you are installing the sensor for the traffic, sometimes pollution monitoring. All these things if you are collecting, so in real time mode you can link this data with the WebGIS. It's a very important application. And like for example, if you are monitoring the traffic control system, or you are monitoring the traffic condition in city, and so your sensors can be directly linked with web-based GIS. In nutshell, if you see the what is this web-based GIS definition wise, theoretically it's basically integration of GIS and internet technology, is allowing GIS professional to solve one of the most important problem inhabiting the information utility: how to provide access to information and data without burdening and users with a complicated and expensive software. So users are not bothered about the software and data, so they are simply accessing as a website and getting all the GIS services. So internet is a perfect mean of GIS data distributed environment. Basically, GIS user can use and download the data by sending the request to the web browser applications. The most important advantage of this technology is dynamic in nature of natures. Basically, for example, if you are updating something in server, so immediately these updates are available to your all the users at the same time. In the traditional GIS, you have to make a duplicate copy of this data or information, then only you can update. But here it's very dynamic in nature. And when I'm saying the dynamic natures, the clients are fully aware of the latest update on the data sets and software application also. And another thing is real-time integration. Already I discussed about it. And another important advantage of this technology is a cross-platform. When I'm saying the cross-platform means basically at the user end, no specific operating system or no specific environment is required to run this GIS. Here, if you are publishing your WebGIS for say Mozilla Firefox or Chrome or any browsers, So these browsers are available for all the platforms, so your GIS will be there. So then we have another different kind of architectures in place here. Two major categories are there: server side applications and the client side applications. If you use the server side application, basically are the GIS applications where the complete data and software is available in the server. So client is given access through any application like browser applications, simple browsers. So client is not installing anything in their local computers. Here normal thin client is also sufficient to access this kind of uh, server application. In the client side application, basically what we'll be doing, we'll be transferring some part of the load, some part of load of data and software to client. For example, Google Earth. In Google Earth, if you want to access the 3D basically platform of Google for the visualization of satellite data or maps, then you have to install the Google Earth. So this Google Earth software will allow you to install it in local computers, so that you should have that much memory space in your local computer, and also should have some RAM to access run this program, and it will store some local data also, so that sometime in offline mode also you can access. So these are the simple architectures. Other than this, we have some mixed architecture also available today, client and server mixed architectures. So this way also you can do it. Now these are the server component of WebGIS. There are four major components basically you have to remember here. As a host organization, if you have any plan to publish your own WebGIS system, one is a database server. For example, you have the options like PostgreSQL and PostGIS, ArcSG and selected RDBMS like Oracle. You can choose the PostgreSQL, you can DB2, IBM DB2 you can choose. There are a number of options available. Oracle Special is another important example of database servers. MySQL and many more such examples are there. So database server is one of the important criteria. Here I have listed the PostgreSQL and PostGIS combination as the first one, and because this is one of the most popular RDBMS in the GIS domain. If you are from the computer science background or you are a developer, and so PostGIS and PostgreSQL will be useful for you to develop and publish your own GIS database for the multi-user access. Next is the GIS server. Yesterday this particular terminology was used, or sometimes it is also known as a map server. Here some options are available for you like GeoServer, which is servlet based connectors are available here. It's a Java platform. UMN map server from University of Minnesota. This is map server product which is based on the CG architectures. Then you have the RGS server from ESRI. You have the Apollo server from the ADAS. There are a number of options are available, but these 3-4 are most popular GIS server. And the application servers, if you see here, so you can develop your own application server, or sometime some vendors are providing the solution for ready-made application server also. But I'm just displaying here some of the popular APIs or the application server interface like OpenLayer API. This is completely a JavaScript based APIs. Recently one more API called Leaflet also is now available in market as an open source. So a lot of things you can do, and you can very easily integrate your server side scripting language like PHP, .NET, Java with these APIs, since these are JavaScript based APIs. And GeoBase is another interesting platforms based on which you can develop your application server, GeoMages, GeoTools, and so on. So these are the popular. Basically, GeoTool is Java based, and other things are supporting different languages. As far the web servers are concerned, there are again many options are available in the open source and commercial platform. Here the Apache is the most popular web server, and Apache Tomcat for Java developers is also available. This IIS from Microsoft, NGINX, GWS, Resin. There are so many web servers, but Apache, and Apache Tomcat are two popular web servers where you can host your WebGIS application. This part already yesterday we discussed about it. Yes, this GIS server also. Yesterday we discussed what kind of facility you will be getting in these servers. So as I named it, like Geo Server, Map Server, or RGS Server, Apollo servers, these are servers basically are providing us this kind of facilities like mapping visualization to catalog. Here down, if you see, yesterday we have not discussed much about this concept is basically called Geo RDBMS. I was telling about the object orientation in database. It's basically if you allow any in any RDBMS to store our vector and raster data, it is known as a Geo RDBMS. So PostgreSQL and PostGIS combination can be considered as one of the example. Oracle GeoRaster is another example. In fact, IBM DB2 with their special extension also is permitting you to store the geospatial data in RDBMS. Here there is no file systems basically. We'll be using only the database servers. And another important standard what will be in practice is called extensive markup language. It will allow you to the interoperability in the GIS data and services. Now, if you see the role of each components, what basically it will do, the database server, as its name itself is very clear that it is a relational database management system, or DBMS or RDBMS, which will allow you to store and manage your geospatial data. And when I'm saying that store and manage, then it will give you the effective way of storage, and also it will give you some ready-made tool to manage this data properly in terms of performance, in terms of security and backup and data recovery and so on. So these are some advantages. And if it is a GIS servers, yesterday it was clearly it was told that it is basically a component between your application server and database server. The major role of the GIS server is to convert your geospatial data in web compatible formats, and also it will be responsible to take the GIS base request from application server and send this request to the database server and take response and process it and present to the application server. So application server is again software which provide customized software application basically as per the requirement of any theme. Like GIS server will be generic in natures, but when I'm saying the application server, so I can say that this application server is giving me application for urban planning, application for land resource management, application for disaster management, and so on. And web server, most of the people knows it about. Basically it is a server is a computer program which uses the client server model and the World Wide Web's hypertext transfer protocol serve the file that form web pages to web users. Basically whatever data you have in the database or in the HTML file, it will be presenting to the users. In this era, another important terminology which is very popular or which is being used in GIS is basically implementation of Web 2.0. So Web 2.0 is basically a terms which was this first time used in 2004 sometime. Is referred as interactive web applications with public participation, which allows participatory information sharing, interoperability, user-centric design, and collaboration on the World Wide Web. The integration of Web 2.0 with GIS data application is known as Geoweb 2.0. So when I'm saying that Web 2.0, it is basically a latest advancements in GIS which makes your web page more interactive by including the AJAX kind of architectures. AJAX is a asynchronous JavaScript and XML support. So basically typical example of Web 2.0 implementation is today the social media website like Twitter, your Facebook, or maybe WhatsApp. Here without refreshing the web applications, automatically you are getting the updates from the server. So this is basically syncing the client and server as a background process. When you are doing this in Web 2.0, in this particular slide, you can see here the background technology and outcomes are displayed as a yellow color and background technology as a dark green background. You can see here. When I'm implementing the Web 2.0, so I have the technology like extensive markup language or RSS feed like really simple syndications, JavaScript, AJAX, and so more. Many more such applications are technologies are there today. So like another example can be your YouTube, where the real-time streaming protocol is used Continuously you are getting the stream. Same thing the way I am delivering talk from Dehradun and you are receiving at your end using the streaming protocol. So here you are not refreshing your page at all. If in between also the internet is disconnected, so automatically as a background process our this software like ABU will be keep on tracing the connectivity, and whenever it is established automatically displayed, it will be connected to the users. So this is a typical examples where the web 2.0 is implemented. Here the idea is to present web as a platform and to include or to incorporate more user participations and content syndications, web services and all. So what do you mean by content syndication? And this concept of the content syndication is very popular basically in the new channels or the medias. Basically when they are updating any news in their server, automatically it is available as a RSS feed so that the updates will be available in desktop. You must have observed this in your mobile phone and also in desktop applications. If you are installing these softwares for receiving the feed from the multiple media channels, so without visiting their websites, you will be getting update in your desktop itself. The same concept basically is used for the GIS activities also. So here we have to understand the RSS when I'm implementing for GIS, it is known as GeoRSS. So basically location information also will be including. Nowadays many advanced or many international websites from the media channels are also providing the GeoRSS. So whenever any news is coming or any updates are coming, so automatically it will pinpoint the location on the map. It's very important if I'm getting this kind of feed where the geolocations of the event is also located, so easily I can do the many analysis on top of it. Based on location based analysis I can perform it. So now it is becoming popular slowly. And then here you can see here definition wise web 2.0 can be realized by combining several web computing technologies such as AJAX, OpenAPI, REST. So basically another example of secure web presentation, XML, XHTML, CSS, RSS, GeoRSS and other related technologies. Getting very popular, and same thing is basically we'll be using in GIS. This particular slide already we discussed yesterday. Now I raise one question that what is web service? So here we have discussed yesterday that web service is not a website, but web service can be accessed in the website or without website also. So for example, suppose you are publishing a RSS feed. So here you go back and see again, this is the RSS feed. This can be considered as a service. It is not a website. Here this RSS feed is coming from any media channels, or maybe any agency can publish this feed. So this is not a website. To access this feed, it is not necessary every time I have to visit to the website of that particular media channel. So directly it can be available in my own application. So this is one typical example of a general example of our web service. In GIS domains like satellite data from ISRO Bhuvan portal is available as a service. What do you mean by service? A service means they will give me one URL, and the same URL I can use as a GIS layer inside my GIS package. If it is not available as a GIS service or web service, then if I want access this data, so necessarily I have to visit the website of this particular organization like one portal, then only I can access. But in the service oriented architectures, here you can see the satellite image from the Bhuvan is a typical example of web service. Then we'll also learn how to use this web service in later stage of this particular program. So here when I'm saying Geoweb, this is another interesting terminology. In 2010 first time this word was coined, Geoweb. It is known as intelligent GIS basically. When it is available in internet, Geoweb. So here the multiple technologies can be integrated together. For example, some data you can take from the smart mobile phones, some data you can take from the database servers, and some data directly you can consume from the websites also. So here when I'm consuming a data from website, it is similar to make available my website as a data. Although it is not operationally available today most of the time, it will be known as a semantic web in coming years. Here, basically, whatever data is published in the website directly I can consume in this smart GIS. There are so many applications are available. You can search for the Geoweb or mashup also we call sometime. Some mashup architectures for like disaster management, emergency situation, all. There are n number of case studies are available. And geotagging is another important basically area where people are having the interest nowadays. Whatever assets are there, whatever photographs or my activities are geotagged. This is the similar way what I have discussed about the RSS feed, and when you are geotagging the RSS feed, it's called the geo RSS. So geotagging of the photograph, media contents, and so on is also in progress, or people are doing this. Now then, to do these all activities, we have to understand one important architecture called service-oriented architectures. This architecture is popularly known as a SOA architectures, SOA. Here it has the three important components. One is basically service broker, service providers, and service consumer. If you see, the service provider are basically originator of the service. So if I have this say land use map of my region, so what I will do, one way is very simple. I can publish this data in my website and my users can see it. But when I'm publishing my data in my website, so very limited kind of user will see this data, basically, because in website I will customize and modify this data the way I want. But suppose the users is interested to use this data in some other way, and then the things will be totally different. And then in this case, the service provider basically will be publishing the service, and when they are publishing this data, they will be basically registering this service in a service broker. It's like a service registry. So here the service registry will be responsible through which the consumer or client will be searching for the service. So yesterday I was talking about the catalog services, and these are the catalog services are basically a typical example of it. So service brokers are basically or this particular component is responsible to register a service, and the consumer is directly not connected with service provider in initial stage. But when the service is available, then this particular component service broker will disconnect, and then it will set up a direct communication between the custom client and server. Here through the internet this will happen. For this communication, one protocol will be responsible called the SOAP, Simple Object Access Protocol. So this protocol will be responsible to set up a relationship between these two service provider and service consumer. This is very important here. Yesterday I talked about few protocol like TCP/IP protocol, and today I am saying the SOAP protocol. So of course the SOAP also will run on the top of the TCP/IP. So TCP/IP is general protocol which will be responsible to make the connectivity between the client and server. But when connectivity is set up, then SOAP will be protocol responsible for the communication. So communication between two applications. Application A want to communicate with application B, then here the SOAP protocol is responsible for that. So in this system, completely the major or most important objective is to achieve the interoperability, because the hundreds or thousands or millions or billions of users are creating different kind of data set in different formats, and we want to set up interoperability between the data. So how to do it? If you try to understand how the technology has grown, it starts with the simple file-based system to the network and hierarchical system, then DBMS and RDBMS, and today we are talking about the XML and SOAP, where the service architecture is in place, and maybe in futures we are moving toward the semantic web, where you'll be using web as a data. So this way the technologies are growing here today, and this particular program we are focusing on this part, where we are saying that wherever data is coming either from the flat file system, network, hierarchical, or DBMS, RDBMS, or ORDBMS, ultimately we'll be publishing this data as a service, and in the service oriented architectures it will be consumed. So this way the things are moving and technology is advancing nowadays. When we have this SOA and now GIS separately, when we combine this or integrate the SOA and GIS together, so basically called as a integration SOA with GIS, this particular slide is showing you how this integration has been done. So first question will come, who is doing this integration basically, and here for this purpose the standards are designed and developed by one international organization called OGC, Open Geospatial Consortium. We'll be seeing what is this organization in coming slides. You see here, it's a very interesting architecture is published. Here, typical example you can see we have again three important components. One is a publish. Publish, when I'm writing it, it is basically publishing of my data. So I can publish my data in different way. Here more than 50 data standards are published by OGC. Like I can publish my data as a WMS, I can publish my data KML, I can publish my data as a WCS, I can publish as a WFS, SOS, SF, and so on. And when I'm publishing my data, so first I have to define from where I will be taking this data. So of course data is stored in database server, and this database server could be a RDBMS or ORDBMS in commercial mode, or maybe open source, doesn't matter for me. And here I can consume or I can make a connectivity with my database servers, and then I will be publishing this data as a service. And when I'm publishing this data, very important point is what encoding I am going to apply on this data, because when my user will be accessing this data from other site, so encoding is will play very important role, very important role it is going to play, because for example if it is in a some style layer descriptor. For example, if I publish my web service as a WMS, then how I am presenting my legend. So here on top, because legends are basically a kind of index of my data sets, so legend will be defined by SLD, and but my other users want access either my map or my legend. So for both I have to define the encoding. Very important terminology. So if you see in internet now, the UTF-8 kind of character sets or encodings are available, where we are defining how to present or how to display my web page at the user side. This is the same way it will define, or it will give us the technology or technique to present our data at the user's machine or client machine. So here different encoding techniques are also available as a standard from the OGC side, and these techniques basically will be responsible to present the data information to the users. So when I'm doing this, so all the data will be published in my catalog service, and encoding will be available for the as a separate components. So to make a relationship or linkages between my service and encoding, so I have to bind it. So binding will be basically done by broker, service broker, what I called in last slide. Here in the client side, basically what client is going to achieve is first it will search my data from this catalog. This is called catalog service, and catalogs are based on the published service either in the WMS and other formats, and then it is available to the users. The response of binding also is through the encoding is possible. Although this is for the data purpose, but parallelly the complete service oriented architecture is also implemented for the processes like web processing services. So here different standards are again available, like discovery service, web processing service, nowadays navigation service, and we have the coordinate transformation service. I was telling that since data is available in the WGS 84 or geographic coordinate system, GCS WGS 84, and you are willing to use this data as a in UTM projections or maybe in LCC projection. So for this purpose, your coordinate transform service will be responsible for that. If this service is available, basically it will have the parameter for coordinate transformation. By reading this service, I can online do the online change of projection in my GIS software by reading the parameter from this service. This is a little technical part. If you are not having interest, you can skip, but just you should have in mind that when you are implementing SOA for GIS, then OGC is the organization which will design the standard for that, And here again 3 components are designed, basically one for service publishing, second for service registry like catalog, and third for encoding methods. So by combining these 3 things, we can present our GIS data to the users. So if you see the standard for web services other than GIS in general standards, the HTTP already we discussed yesterday in details about this particular protocol, and SOAP already today we discussed. Basically I told it is a communication protocol used for exchanging data and message between two systems by HTTP. And then we have another important standard here called Web Service Description Language, or WSDL. It is used to describe type and other characteristics of the web service using public interface. And the Universal Discussion, Discovery and Integration, this is called UDDI. Basically it is a service registry. The UDDI specifications are used as a service registry. Through the UDDI, the service providers advertise the existence of this service, and by requesters to search and discover already registered services. So here you can search. So these are the basically 4 important technology or terminologies you have to remember here: HTTP, SOAP, WSDI and UDDI, which is important for SOA. As I told you, in OGC basically is an open geospatial consortium. You can visit their website. One of the most popular or most important organization in this service oriented architecture for GIS came in existence sometime in 2000, and their vision is to develop the standard for geospatial web services. Either it is a data service, visualization service and so on. I will be giving you example of it. Their mission is basically a world in which everyone benefits from geographic information and service made available across any network, application or platform. So they are trying to establish the interoperability between different networks, different kind of data and application and also platform. So this is the very important organization. Then what they do actually, the OGC provide the interoperability, and the OGC specifications are agreed upon by the broad constituency of the geospatial community and are supported by many software vendors, either it's open source community or commercial community. So they are supporting the OGC standards, and OGC links geographic data with mainstream information technology. This is basically these standards are playing very important role to make the compatibility of connectivity between IT and GIS. So they are very important organizations for that point of view. And vendor implementation in product enables the direct access and use of data product by program from many vendors. So then OGC also collaborates and work closely with the international organization for standardization called ISO chapter basically 211 and 204, and World Wide Web Consortium, that is W3C, Internet Engine Task Force, IETF. Yesterday I named this particular organization when I was briefing you about the internet technology. The Automotive Mobile Information Consortium, Mobile Alliance and so on. There are so many organizations closely working with OGC. So when we are coming to the web service specification for GIS, so we have the basically 5 major categories. Under 5 major categories, we have today more than 50 standards available from OGC site. First, let us take as a catalog service. The example of catalog service is like CSW, EBRIM, CSW, 19115 and so on. These are basically the services responsible to register the metadata. These catalog services are for metadata. So again for the metadata also, under the catalog service, CSW is most popular metadata standard or service standard basically for GIS data. Next component is processing services. Suppose you are developing a model or you are developing some GIS process, so you can use some existing service standard like sensor planning services, SPS, web processing services, coordinate transformation services and so on. Basically, or web coverage processing services are also the latest development on this area. So most popular processing services available in internet today is WPS, web processing services. Here basically idea is they will take the data input from multiple servers or from multiple users, and then it will run the process on server side and present out to the client. So encoding, already we discussed about it. The example of encoding services are basically GML, CityGML nowadays, and then filter encoding service like FE and GML for in JPEG. You have the SLT, style layer descriptor. This standard is for the legend, basically. The classification what we display in GIS is a SLT, and the TML is a transducer markup language. So these are the some standards available from OGC, but here you have to remember CSW for catalog, web processing, that is WPS for processing, and the encoding purpose SLD. These are the three major service standards what are available today in internet as a operational mode. So you can use these things in your GIS and you can build your own GIS project or application. In case of data services, we have some example, like for the vector data, we have the WFS. When I'm saying that vector services mean or data services means the original data is flowing from server to client to and client to server. So when it is a vector, for example, the host organization is maintaining their data vector data in SAFE file format, and the user want this data in some PostGIS format or maybe SVG format. So if it is published as a WFS, so online this data can be converted. So basically here there is no visualization. It's basically only for the data, actual data. So when my vector data is available as a WFS, then I can perform all the vector operation on this URL, like my intersection, union, buffer analysis, and so on. If this data service is available for raster, which is known as a web coverage service, WCS is completely for raster. Here I can perform all the arithmetic operation what I can perform simple raster file. So this is a very important service. In general, nowadays people are not using the data services. We are only using the portal services like WMS or WMTS. So portal services are example like for visualization. Only map visualization, either it is a satellite data or map, we can do using the portal services. Here WMS and WMTS are basically example of that. Web map services and web map tile services, and there are many other services under other categories like GeoXACML, GeoRS, Geospatial Objects, OWS Common. If it is a GeoXACML, it is a GeoXACML. It is a basically for the Web 3.0 semantic web, when you will be presenting web as a data. So GeoRSS is another example of the other category services. These are the 5 category you can say, and more than 50 standards are available there. When you are saying that WMS, most of the time it is only for visualization. You cannot do any kind of data processing with WMS. Always you have to keep as a background layer, then maximum you can digitize the other layer, then you can use it. Otherwise, no, it is a visualization service. But when you are looking for the data processing or data analysis, you need a WFS or WCS. These will allow you to access the original data for your GIS data processing. So here you can see geospatial web service flow example, how it will do actually. If you see the content in the feature or coverage, here feature means vector, coverage means raster. So data accessing through data services, visualization through portal services, data discovery through the catalog services. So this way people are doing it. These are the some listings, may not record, already I discussed about it. These are the some most popular approved specification from OGC site. Yeah, this is a very interesting architectures what OGC has published. So it talks about different data standards format like vector and rasters, and how this will be published and how this will be consumed in internet. If you see here, the for example, if you take the vector from the SAFE file or database, so nowadays you can store your raster as well as vector in database. If you access this as a feature data or as a map drawing a map visualization purpose, it will give you outcome as a WMS. It can give you output as a GeoRSS, can give you output as a KML and WFS, and these all things you can perform using a GeoServer. Here I have given, this is just an example. If it is a GeoServer, And the Geo server, basically what is a GIS server, what we are saying here, it can do this activity, basically publishing this data in these different service standards. Either it is a WMS, WFS, WCS and so on. Once this is done, the role of Geo server is over. The GIS server responsibility is done. So next part you have to perform in the application server. So once I'm getting a WFS, then how to build a query builder on that for the vector data. That is the responsibility of the application server. So that's why I'm telling you the open layers or geo tool, these are the things which will allow you to do this kind of operation in your web portal. And then you have the outcome as a map viewer, feature viewer or editors, Geoweb or RSS viewer, KML viewer and GIS viewer and so on. So finally in the web browsers, you can use the open layer APIs like JavaScript and map. Web server will allow you to publish this data directly in Google Earth also. And then compatibility with web browser, again you can use the other product called Geo Network, where Geo Network is another product which is responsible for the metadata. So using the protocol JET 39.50, you can make a communication between different metadata servers. So it's very interesting architecture. If you spend some more time on this, so you'll have that some fair idea about the how the communications are happening in GIS domain for the web services. So what does all this do for you? As a near instant data interoperability, it support web-based service architectures. No more data configuration management, nothing is required. Directly you consume these services in your local computers. And today, based on this, how the mapping is being done in the internet, you can see here geoportals are increasing day by day. There are number of geoportals are available, right from, if you see, the Google is giving lot of information as just map visualization or slide data as a background. Bhuvan also have the similar kind of interface for use in India. And then we have the interesting project like OpenStreetMap, which will allow you to do the complete mapping activity in the browser itself. And also you can download this data as a zip file or as a XML file very easily. So we have the some like bioresource related information services from our side, from IRS side. So there are a number of portals available, and this is basically most of the time they are available as an information system. Very few are there where the data is available as a service. If you see the another important, I think animation is not coming here. You can see here there are a lot of multimedia contents are also displayed on top of maps. You can see the animations, you can see the movements. If you visit our Bhuvan portal, you can see the during the cyclone time, the complete real-time movement of the cyclone also is visualized. You can also do a lot of route alignment, optimization of the route, nearest route, and these things you can do. So complete animation activities or multimedia integration with maps or web portal or geoportals are also happening here. So another important interesting development in this domain is 3D visualization. So this particular technology is not limited to 2D visualization. Here you can see some examples are shown, especially in your ISRO Bhuvan portal. If you see, you can completely draw a profile. You can see the 3D view of a terrain, and you can see the how the terrain is varying, and very clear-cut idea you'll have if you are having planned to make an infrastructure here. So it will give you the complete height variations. You can visualize, you can see the synoptic view. For defense purpose, you can plan where I should make my own base camp to do this all the operations. You can also do this same concept nowadays in internet using the like this kind of 3D city plannings. You can nicely build very beautiful city models. This is a typical example of Taj Mahal, what Google is presenting nowadays in Google Earth. And similarly, you can develop your own models. And the city planning completely are possible in this particular technology. You can do all these in browsers, but same time you can also access into your local GIS platform. We can have many example here. Some of the 3D GIS example I'll be demonstrating you in the coming sessions, where you can understand that how this real-time like contour creations, slope aspect, I can simulate the scenarios that if water is flowing from this direction to this direction, so how much water will be available and so on. So these things are happening in internet nowadays for GIS, and In India, one common platform called ISRO Bhuvan Geoportal. Maybe next session I will be covering in details. You can create your own 3D globe here, and the main focus on India. Here, the different kind of data sets are available as a service or as a website, as 3D globe also. So very important thing is how we can use these things in your local computers for our own planning activity that we will learn in the coming lecture sessions. Let us quickly see, based on this service-oriented architecture, SOA or OGC standard, what are the popular websites or web portals today you are using, or you may be aware of it. But if not aware, quickly I am listing here. Google Map is one of the most popular website today. In 2005, they came in existence, and they provide a global satellite images and the maps in 2D and 3D at the street level with the various applications. Here, although it is basically a web-based GIS, but it's not truly is basically open web service, or it's not based on OGC standards. You can do a lot of things in Google website. You can use this data, you can make your plan, but if you want to use this Google data for your own planning activity, some limited softwares are giving you plugins for this, but as an open OGC standards not available. But yes, it's most popular, and a lot of interesting tools and applications are available. Another interesting application in internet is a Bing map. Basically address is given here, bing.com/maps. Again, it is from the Microsoft. It's basically global satellite image and map, and they are more in their strength is basically the infrastructure layer, road network, and so on. OpenStreetMap is another interesting project. You can always access it. I feel for the GIS professionals and users, and this particular website is becoming most popular website. So you can see here the openstreetmap.org. It gives you the open and free vector data and collaborative mappings. So you can download all the vectors on 1:10,000 scale as a SAFE file also. So that is very interesting fact. And this data is created by the public for the public. So also the validation part also is done by public. So here very interesting data sets are available. We'll be covering sometime how to use OpenStreetData website to download the data. Mapping is another crowdsourcing approach for the tagging ground information. So although they are not giving any data, but yes, you can tag the different ground information in the map. In India, ISRO Bhuvan is a very important portal. It is basically becoming as a platform. It's not only website. It's a rich contents and seamless availability of multi-temporal, multi-resolution satellite data for entire Indian regions. And the strength of this portal is the thematic and disaster services. And today, many ministries and government-related projects are also hosted in these platforms. You can see these data sets, and also the thematic contents are very rich in the Bhuvan portal, which is not available for India in any other portal at all. So you can see from the ISRO site, we'll have a two special session on the Bhuvan. So it's available. Then we have the Map My India, another commercial player in India. You can say very good data sets for India is available in their website, like maps.mapmyindia.com. It's a rich point of interest and detailed maps of India. So they are available in the commercial mode, but if you see the content wise, it's really good data set. So another important website for or geoportal for India is Indian NSDI from Departments of Science and Technology, Government of India. It's nsdiindia.gov.in, and they have very good compilation of metadata catalog and policy documents. You can search for data sets based on their characteristics. It will redirect you to respective organizations where you can get the actual data sets. This is one of the very good initiatives from the Government of India side. And the biodiversity information system from ISRO side is another interesting portal where the biodiversity special viewer and data download facility is available. The complete vegetation type map, fragmentation, biological richness, or maybe other index fragmentation and all, you can completely download as a physical data set in the raster format. Original data also is in raster, and the same data sets are also available as a service. We'll have a full demonstration on that during the session. It's a very quite interesting. So you can consume it, and there are a number of utilities and tools are available to access this data and present the report at the user end. Another important initiative for Bioresource Information Network is the Indian Bioresource Information Network. This is basically a integration of multiple bioresource centers in India. You can say it is a SDI for the bioresource in the country. So special data infrastructure for bioresource here. Many bioresource information centers are linked with this, and the rich data contents for Indian bioresource information system for distributed database architecture. It basically follows the complete service-oriented architectures where the tabular data and map data both are available as a service. So India Water Resource Information System is another interesting development which is operationally available from the CWC website india-wrs.nrsc.gov.in and developed by ISRO, and now it is completely transferred to the CWC, and it has the rich data content for water resource of India, either surface water and groundwaters. The complete information you can download. It's a very big portal, I can say, for the especially for the water resource of the country. From the NIC site, they also have very nice GIS platforms called as a gis.nic.in, and this particular platform offers basically the demographic data up to the village level with the tagging of the information in the GIS domain. Because NIC is having the rich content on the attribute, basically management information system. They have the excellent MIS for the different user department ministry in the country, and so they are trying to link all this data, attribute data, with GIS data. I found this is quite interesting applications. So you can visit their website, and I think Bharat Map of some new terminology they have given recently. It's an excellent platform basically to linking the village information with GIS map. So these are the few portals, geoportals in India, which you should aware of it, and we'll